Okay, welcome. This is another technical technician video from Diagnation. In today's video, we're going to call Honda idle speed control, math channels, and duty cycle. Take a snapshot of this schematic in front of you, and then I will explain each part of it and what we're going to see on the scope. We're going to basically scope the idle air control valve on this 2004 Honda and look at the duty cycle. We're also going to look at the relationship between inputs and outputs, between load inputs at idle and the output from the PCM controls the idle air control valve by changing its duty cycle, and hence the duty cycle, the idle air control valve will move that throttle there, or that bypass the throttle plate to let more or less air go past the throttle plate to increase or decrease the speed. What we're going to scope here, we're going to have one scope lead on the duty cycle control at the PCM. A second lead is going to be at the power steering pressure switch. Now I'll talk a little about the power steering pressure switch. This is an input to the PCM when the power steering pressure gets excessive, as if the car were parallel parking, and the lugging of that power steering pump on the engine would have to up the idle speed. The PCM would have to up the idle speed and would command the IAC to change its duty cycle to get more air past the throttle plate to give us more RPM to compensate for the load. That power steering pressure switch is basically a circuit. It's just a normally closed switch when there's no load on the power steering. When you attempt to turn the steering wheel to an extreme and the power steering pressure builds up, it actually opens. So we're going to be looking at, on channel C, we're going to be looking at the voltage on that signal. We're also going to be we're going to have a micro clamp looking at the current on that signal, which isn't commonly done, but I think it has a lot of diagnostic advantage when we think about it, because that's basically a circuit. That's a 12-volt feed out to the power steering pressure switch, and internal to the PCM there's a resistor that 12 volts goes through. That is essentially the load of the circuit. So basically the logic part of the PCM will monitor, as you can see right here, it will monitor voltage at that point right after the resistor, and it will determine whether the voltage is high or low. When the switch is closed, the circuit's complete. It goes through 12 volts through the resistor, through the closed switch onto ground, and it does flow some current, as we'll see on the scope. That is, you can see the micro clamp on channel B. The micro clamp with the red arrow is pointing in the direction, the way I laid it on the wire, that is away from the PCM for that initial test. You'll also see some dotted lines, some hash lines on other channels. I will switch that micro clamp to the duty cycle later, just to see the current flowing through the driver, also flowing through the idle air control valve. You see the red arrow is the direction in which the current's flowing, and that's how I have the arrow on the micro clamp pointing toward the PCM on that capture, pointing away from the PCM on that capture. We're also going to look at crank speed. That is channel orange, we'll see on the scope. And because crank speed is a good validator, it's kind of that RPM change. I will make math channels. I'll make a frequency math channel to see our RPM change, and you'll see that. So we got 4 channels there. Just want to point out, the PCM will use its logic to take on information from various when there's a load on the engine, an air conditioning load, an alternator load with electrical load. You'll see that where the AC comes on, and then it would have to change the duty cycle to compensate for the load of the AC compressor. So basically, internal to the PCM, you see a driver that the ground controls the IAC valve, and the current flows from the solenoid through, and it will duty cycle. Changing the duty cycle will change how much that IAC is open there, and hence how much air flows past the throttle side of the throttle plate. Will actually go around the throttle plate and give the engine more airflow, hence more speed. So let me go to the scope, and we'll take a look at a bunch of captures. I'm probably going to shoot this in a few parts. I'm going to try to concentrate. I will explain the math channels in good detail so you can understand them. We'll have 2 math channels at once on the screen.